Hi student, my name is Professor Prakash Vasankar. Today I meet you again through my YouTube channel and today we solve some MCQs on straight lines for MHTCET and JEE or Maharashtra State Board Exam 2022. So first here MCQ is this is the first MCQ. I solve all the MCQs in questions paper JEE main. So first MCQ is a triangle with vertices 4 comma 0 minus 1 comma minus 1 3 comma 5 is option A isosceles and right angled. Option B, isosceles but not right angled. C, right angled but not isosceles. D, neither right angled nor isosceles. So here vertices of the triangles are given. And in this option, that is in this multiple choice questions, four options are given. So first we find the length of the sides of the triangle. Suppose here we assume that the triangle ABC, then vertices of A is 4 comma 0, B is minus 1 comma minus 1 and C is 3 comma 5. We assume this. And then we find here AB, BC and CA by using the distance formula. And we know that the distance formula, that is under root x2 minus x1 whole square plus y2 minus y1 whole square. Distance AB is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square. We use this concept and find out the sides, find out the sides of the triangle. That is the three sides of the triangle. Again, we repeat this. We find here AB, BC, and CA. For this, we use here the distance formula. We know that the distance formula, that is distance AB is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square. So we use this concept here and find out first length of the side AB. Use here distance formula. Under root here, under root 4 plus 1 whole square, 0 plus 1 whole square. So I write here 4 plus 1 whole square plus 0 plus 1 whole square. 4 plus 1, that is 5, 5 square. Here 25. 25 0 plus 1, that is 1 1 square. 1 25 plus 1 under root 26. So here length of the side AB is equals to under root 26. Similarly, we find here the length of the side BC. We know that the coordinate of the vertex is B and vertex is C in the problem. Here coordinate of vertex is B, that is minus 1 and coordinate of vertex is C 3 5. Then we use here the distance formula and length of the side BC is equals to under root 3 plus 5 whole square plus 5 plus 1 whole square. So we write here 3 plus 1 whole square plus 5 plus 1 whole square. 3 plus 1, that is 4, 4 square here 16. 5 plus 1 6, 6 square 36. 36 plus 16, so which is equals to under root 52. This is the length of the side BC. Next we find by using the distance formula length of the third sides of the triangle, and that side is CA. Again in this problem, coordinate of here C 3 5 and A 4 comma 0. So by using distance formula under root 4 minus 3 whole square plus 0 minus 5 whole square and find out the length of the third sides. So 4 minus 3 whole square, that is 1 square, 0 minus 5 minus 5. So minus 5 square here 25, 25 plus 1 26, so under root 26. Therefore here from this it is clear that the side AB is equals to side CA. That is here the two sides are equal, therefore the triangle is isosceles. Next we use here the Pythagoras theorem. And if Pythagoras theorem is satisfied, then the triangle is right angled also. So by using here Pythagoras theorem in triangle ABC, by use here the Pythagoras theorem, that is here BC square is equals to AB square plus AC square. By using the Pythagoras theorem, BC square, here BC square, that is root 52 square, and root 52 square, that is 52. So right here 52. Then here AB square, that is under root 26 square plus under root 26 square. Square and root cancel. So 26 plus 26, that is 52 equals to 52. Therefore here the Pythagoras theorem is satisfied. Therefore the given triangle is right angle triangle also. Therefore here A is the correct option. That is the triangle whose vertices are 4 comma 0 minus 1 comma minus 1 3 comma 5 is isosceles and right angle triangle. Therefore A is here correct option. So this is one important multiple choice question in straight line. Dear student, if you like my video, please subscribe my channel and press on bell icon. Next MCQ is all here. Next MCQ. Locus of midpoint of the portion. Locus of midpoint of the portion between the axis of x cos alpha plus y sin alpha is equals to p, where p is constant, is option A, x square plus y square is equals to 4 upon p square. Then option B, x square plus y square which is equals to 4p square. Option C, 1 by x square plus 1 by y square which is equals to 2 by p square. And the last option, option D, is 1 by x square plus 1 by y square is equals to 4 by p square. So in this problem, first we understand the problem carefully and then solve this problem. This is one very simple problem. In this problem here, we find the equations of the locus, and locus is midpoint of the portion between the coordinate axis, and equations of the line is given. This equations is a linear equations, because in this equations degree of x and y is 1. Therefore this equation is called as a linear equations of the straight line, and this line intersect the coordinate axis, and the portion between the coordinate axis, that is here the midpoint of the portion between the coordinate axis, is the point of locus. So here our aim is to find out the coordinate of the midpoint. So for finding out the coordinate of the midpoint, first we find the point of intersections of the given line with the coordinate axis. So here we assume that let A and B are the point of intersections of the given line with the coordinate axis. Then we find the coordinate of point A and point B. Point A lie on the x-axis, then we put y equals to 0, we get the coordinate of the point A. Point B lie on the y-axis, then we put x is equals to 0, then we get here the coordinate of the point B. So first we find here the coordinate of the point of intersections of the line x cos alpha plus y sin alpha is equals to P. That is the point of intersections of this line with coordinate axis. So here, if I intersect this line with x-axis, then we put here y equals to 0. Put y equals to 0. So first we put here y equals to 0. Then in this equation, we put y equals to 0. So 0 into sin alpha, that is 0. Therefore, x cos alpha is equals to p. Therefore, x is equals to p by cos alpha. This is the x-intercept of the line. So we write here, y is equals to 0, then x-intercept is p by cos alpha. This is the x-intercept. And this is the point of intersections of the given line with x-axis. Similarly, we find the point of intersections of the given line with y-axis. On y-axis, x is equals to 0. And then we find here the y-intercept. So we put here x is equals to 0. Therefore, 0 into cos alpha 0. Y sin alpha is equals to p. Therefore, y is equals to P upon sin alpha, that is divided both sides by sin alpha, then sin alpha get cancelled, P by sin alpha. So y is equals to P by sin alpha. So we write here P by sin alpha. And these are the point of intersections of the given line with the coordinate axis. And here point of locus is a midpoint, and midpoint is the portion of the line between the coordinate axis. So here we use the midpoint formula. We know that Pxy is the midpoint of the line segment AB, where A x1 y1 B x2 y2, then x is equals to x1 plus x2 divided by 2, y is equals to y1 plus y2 divided by 2. We use this midpoint formula here. So here, so coordinate of midpoint of AB are, suppose here we assume that P x1 y1 is the midpoint of the AB. Then we find here x1 by adding x coordinate divided by 2. P cos alpha plus 0 divided by 2. Therefore, P upon 2 cos alpha. Here P upon 2 cos alpha. Next we find here the y coordinate, that is y1. Because here point P x1 y1 is the point of locus. That is the midpoint of the portions of the line between the coordinate axes. Then hereby add the y coordinate 0 plus P upon sin alpha upon 2. So P upon 2 sin alpha, P upon 2 sin alpha. So this is x1 is equals to P upon 2 cos alpha, and y1 is equals to P upon 2 sin alpha. Then from this we find sin alpha and cos alpha, because we find here the equations of the locus, and for finding out the equations of the locus we eliminate here alpha. So for eliminating alpha, here we find from this cos alpha and from this sin alpha. So cos alpha, which is equals to, here cos alpha is equals to P upon 2x1, and from this sin alpha, which is equals to P upon 2y1, and here squaring and adding, and then we use the first fundamental identity, we get the required equations of the locus. So squaring and adding, cos square alpha plus sin square alpha is equals to here P square upon 4x1 square, P square upon 4y1 square. From this P square upon 4 take common, then in bracket 1 upon x1 square plus 1 upon y1 square. And here cos square alpha plus sin square alpha is equals to 1. So write here 1, because this is the first fundamental identity. Therefore 1 by x1 square plus 1 by y1 square is equals to 4 by p square. Therefore, the equations of the locus at of point P x1 y1 or at point P x1 y1 is 1 by x square plus 1 by y square is equals to 4 by p square. 1 by x square plus 1 by y square is equals to 4 by p square. Therefore, here D is the correct option. So, in this way, we solve the MCQs on a straight line, and we use here the shortcuts method or some tricks to find immediately the solutions of the multiple choice questions. Next questions. Again, next questions is, this is the questions in pair of straight line, and here the general equations of second degree is given. If the pair of lines ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0 intersect on the y-axis, if the pair of line ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0 intersect on the y-axis, then option A, 2fgh is equals to bg square plus ch square. Option B, bg square is not equals to ch square. Option C, ABC is equals to 2fgh. Option D, none of these. So again, this is one very simple MCQs. In this MCQ, general equations of second degree in x and y is given. And here the pair of lines intersect the y-axis. Then we find the conditions. That condition is given in this option. So we find here the correct conditions. So here again, the pair of lines intersect the y-axis. And we know that on y-axis, x is equals to 0. So put x is equals to 0 in given general equations of second degree in x and y. In this equation, this is the general equations of second degree in x and y. And pair of line intersect y-axis. On y-axis, x is equals to 0. So we put x is equals to 0 in this equation. Therefore, this became 0. This became also 0. So only remaining is here by square plus 2fy plus c is equals to 0. This term contain x and we put x is equals to 0, so this is vanish. This term again contain x, we put x is equals to 0, so this term is also vanish. Next, this term again contain x, we put x is equals to 0, again this vanish. Therefore, the only remaining are three terms, and that are by square plus 2fy plus c equals to 0. So here, by square plus 2fy plus c is equals to 0. And we observe these equations. From these equations, it is clear that this is a quadratic equation in y. This is a quadratic equation in y. It has two roots. So here, for point of intersection, roots are equal. Therefore, the discriminant b square minus 4ac is equals to 0. B square minus 4ac is equals to 0. And here b square, b is 2f. And 2f square, 4f square. Minus here 4bc equals to 0. Divided both sides by 4. Then we get here f square minus bc equals to 0. We write here f square minus bc equals to 0. Then here multiply both sides by a. So we get af square minus abc, a into 0, 0. This term multiply by a, so af square minus bc multiplied by a, abc, which is equals to 0. That is multiply this equation both sides by a. Again, in this problem, it is given that the general equations represent pair of lines. And we know that the general equation, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0, represent a pair of line, then determinant a, g, h, v, f, g, f, c equals to 0. After solving this, we get here abc plus 2fgh minus af square minus bg square minus ch square is equals to 0. And here this af square minus abc, from here multiply both sides by negative sign, here multiply both sides by negative sign, then abc minus af square equals to 0. So abc minus af square equals to 0. Then my condition, get here condition 2fgh minus bg square minus ch square, and this can be written as 2fgh, which is equals to here bg square plus ch square. Therefore here 2fgh is equals to bg square plus ch square. That is, here A is the correct option. Again, which is one simple MCQ, but very most important MCQ for JEE and Maharashtra State CET. Next problem. Again, we solve one problem, and that problem is again in this problem, homogeneous equations of second degree in x and y is given. Homogeneous equations of second degree in x and y. Therefore, this is questions on pair of straight line in class 12. The pair of lines represented by 3ax square, 3ax square plus 5xy plus a square minus 2 into y square equals to 0 are perpendicular to each other for option A, two values of A, because in this equations, in this homogeneous equation, A is constant. So here for two values of A, for all values of A, for one value of A, for no value of A. So if this is a multiple choice questions, homogeneous equations of second degree in x and y is given. And these equations represent a pair of perpendicular lines. And we know that the conditions in the theorem, that is if theta is If theta is the acute angle between the lines represented by x square plus 2hxy plus by square plus by square equals to 0, then tan theta is equals to mod 2 under root h square minus ab upon a plus b. And also the conditions are given if the lines are perpendicular, if the lines are coincident. In this theorem, I know that if the lines are perpendicular, then a plus b equals to 0. That is, in short, we know that the key point, if the homogeneous equations represent a pair of perpendicular lines, then a plus b equals to 0. That is coefficient of x square plus coefficient of y square equals to 0. We use here the same concept and find out the values of a. If I get one value of a, then here we write for one value of a is the correct option. If I get two values of a, then we write here the correct, click the correct options, that is two values of a. So here, these equations, this is the homogeneous equations of secondary in x and y. These equations represent a pair of perpendicular lines. Therefore, coefficient of x square, that is 3a, plus coefficient of y square, a square minus 2, which is equals to 0. That is, here we get one equation, that is 3a plus a square minus 2 equals to 0. So we write here the equation, that is here 3a plus a square minus 2 equals to 0. That is coefficient of, this is coefficient of x square and this is coefficient of y square in the given equation. Therefore 3a plus a square minus 2 equals to 0. Then here this can be written as a square plus 3a minus 2 equals to 0. And this is a quadratic equation in A. It has two roots. That is, it has two values of A. And these are the values of A. Therefore here two values of A. A is the correct option. A is the correct option. Next, in today's lecture, this is the last multiple choice questions. Again, we solve these questions. In these questions or in these multiple choice questions, we find the equations of the locus. Locus is one very important topic in straight line, circle, ellipse, hyperbola, parabola. Again, I request you, if you like my video, please subscribe my channel and press on bell icon. So this MCQ is locus of centroid of the triangle whose vertices are locus of centroid of the triangle whose vertices are a cos t, a sin t, b sin t, minus b cos t, and 1 comma 0, where t is parameter, where t is parameter. And then options are here. Here we find the equations of the locus. And option is 3x plus 1 whole square plus 3y square, which is equals to a square minus b square. Option B, 3x minus 1 whole square plus 3y square equals to a square minus b square. Option C, 3x minus 1 whole square plus 3y square, which is equals to a square plus b square. Option D, 3x plus 1 whole square plus 3y square equals to here a square plus b square. So again, we read here the problem carefully. In these multiple choice questions, we find the equations of the locus, and locus is centroid of the triangle, and vertices of the coordinate of vertices of the triangles are given. So by using the centroid formula, first we find here the coordinate of the centroid of the triangle whose vertices are given. And we know that the centroid formula, if gxy is the centroid of the triangle whose vertices are a x1 y1, b x2 y2, c say x3 y3, then x coordinate of centroid is equals to x1 plus x2 plus x3 upon 3, y coordinate which is equals to y1 plus y2 plus y3 upon 3. We use this concept or we use this key point and find out the equations of the locus of the centroid of triangle ABC. So here, first we find here the coordinate of center, sorry, coordinate of the centroid. So here we assume that let gxy be the centroid of the triangle whose vertices are given. Then x is equals to, here we add the x coordinate of the vertices and divided by 3. a cos t, x is equals to a cos t plus b sin t plus 1 upon 3. This is the x coordinate. And y coordinate of centroid equals to a sin t minus b cos t plus 0 upon 3. So we write this here. X is equals to a cos t plus b sin t plus 1 upon 3. So from this we find here a cos t plus b sin t, which is equals to 3 into x, 3x and minus 1. 3x minus 1. From this a cos t plus b sin t, which is equals to 3x minus 1. So write 3x minus 1. From y coordinate of the centroid. So y coordinate which is equals to y coordinate is here a sin t minus b cos t plus 0 upon 3. So right here y is equals to a sin t minus b cos t upon 3. Again a sin t minus b cos t which is equals to 3y. Here write 3y. Then squaring and adding these two equations. That is these equations, here arrow is given and here arrow is given. So we square and add these equations. So right hand side square is 3x minus 1 whole square plus 3y square. Then LHS square is a cos t plus b sin t whole square plus a sin t minus b cos t whole square. And then we use here the formula is a plus b whole square, a square plus twice ab plus b square. Then here twice ab cos t into sin t get cancelled. Twice AB cos t into sin t, this is positive. Here minus twice AB cos t into sin t, that is negative. So minus twice AB cos t into sin t get cancelled. Then a square cos square t, and here a square cos square t, here a square sin square t. So from this a square take common, then we get cos square t plus sin square t, and cos square t plus sin square t by using the first fundamental identity, that is a square. Again here b square sin square t plus b square cos square t, b square take common, sin square t plus cos square t, that is 1. So a square plus b square. So here write a square plus b square. And this is the equations of the locus of the centroid of the triangle whose vertices are given. That is 3x minus 1 whole square plus 3y whole square is equals to a square plus b square. So here 3x minus 1 whole square plus 3y square, which is equals to a square plus b square. This is the equations of the locus of the centroid of the triangle whose vertices are a cos t, a sin t, b sin t minus b cos t and 1 comma 0. And here t is the parameter. So we eliminate here the parameter t and to form the equations of the locus of the centroid. In this way, we solve here 5 MCQs by using the key points, some tricks and shortcuts method. Again here, dear student, if you like my video, please subscribe my channel and press on bell icon. अगर आपने चैनल को सब्सक्राइब कर दिया तो इस टाइप की जो भी नए वीडियो है वो आपको मिल जाएंगे. ओके, चलो, थैंक्स.